Welcome to Programming in Modern C++. We are in week 5 and I am going to discuss module 24 in the series of inheritance modules now. So, in the last module we have understood the need and use of protected access specifier, which is very critical to provide the extension of the encapsulation information hiding framework in combination with the is a hierarchy or inheritance. We discussed the construction and destruction process of the class hierarchy and the related object lifetime. So, in a way we are now equipped with the basic C++ features for support of inheritance, support on a is a hierarchy. So, it is time to now look at a small example to get a comprehensive idea about how to put all this together and design a hierarchy of concepts in terms of C++ code from the abstract is a hierarchy or is a relationship of multiple concepts in object oriented analysis and design. So, this module will focus on that using the hierarchy of phones, simple hierarchy of phones that we had introduced earlier in earlier module. So, this is the outline which will be available on left. So, we start with is a hierarchy design by inheritance. So, there is no very strict process to do the modeling and implementation of the hierarchy using the inheritance in C++, but I have tried to highlight a kind of flow that you can adopt to for your cases whenever you need to do that. So, I am calling this a kind of overall approach to modeling hierarchy. Now, I will start from the second point, I will come back to the first. So, the key of this design is identifying the concepts and their is a relationship to define the hierarchy, right. So, because it is that real world. So, this is something which you will have to capture from the real world, understanding what is happening in the real world and see what are the different concepts which are on one side kind of similar, kind of related, but at the same time they are not the same. So, there are variations between them which we are trying to capture by the is a relationship, and we will try to model that with public inheritance. That is the first step, that is you capture the is a relationships. Once you have done that, then you will need to identify the interface for each concept. That is, to deal with that concept, what does a user need to do, right, or how does the concept manifest itself. So, that will proliferate in terms of signatures of public member functions, which you need to identify. So, this interface identification for every concept on the is a relationships, is a hierarchy, is the next step to perform. Now, that will still remain abstract, because you are just giving an interface which does not say how to implement that. So, for implementation you have to identify the state variables, or in other words data members, for each concept which can keep information specific to that concept and help the interface or the method or the member functions to use those values of the state variables to actually provide the service to the user. and along with that you will need to create proper encapsulation with the use of private or protected access specifiers. So, with this having done this, you will now have the original is-a relationships, you have the concepts modeled in terms of tiny or maybe not so tiny classes. So, now you will have to link them by inheritance. So, these individual concepts will now have to be interrelated with the is-a relationship by providing the inheritance public inheritance mechanism that C++ has given. We have to probably we will try to provide an abstract or pure interface. We have not yet discussed it in the context of C++, but it is just a conceptual interface which maybe everything in that hierarchy or most of the things in that most of the concepts in that hierarchy should be supporting. And then we will have to refactor common data members, because in terms of this we will find that there are lot of data members in different concepts which will be common. So, we will try to put the common ones more towards the base classes or higher in the hierarchy, and use the member functions to be specialized or generalized as the cases may be. Once this is done, then you are ready with your classes in the hierarchy, put it all together. This refactoring is very, very important, as we will illustrate. Put the classes in the hierarchy, and once you have done that, keep option to explore extendability. Normally, the hierarchy that you create in terms of is-a relationships is not a closed one. There may be more concepts that come in future, and you may want to keep adding to that. So, explore that extendability, and this is to put in brief could be a broad approach that you can take to design the hierarchy and code it in C++. So, we illustrate with the phone hierarchy. Now, before I start doing it, you will find that these concepts on which you are actually building the hierarchy will often need to use a lot of other concepts, maybe small, maybe little big, which are not related to this hierarchy, but these are like user defined types that will be good to have very compact representation, readable as well as encapsulable design of the entire hierarchy. So, this is what I call as helper classes. So, for example, since we are dealing with phones, naturally irrespective of where I am in the hierarchy, what type of phone, you will need to deal with phone numbers. So, I want to define a class for phone number, which keeps 12-digit phone number. There could be further details inside of this class, which say whether it is whether you have international country code, whether you have STD code as a part of it, or it is just a mobile number, whether you have any other kind of structuring information in the phone number and so on. You can have lot of those, and in this current discussion we are not getting into these aspects of the design, because we are not going to do the design on the phone numbers, we are doing the design on the phones. So, we assume that there is some helper class called say phone number is already been designed or will be designed. We can just have it as an incomplete class to start with, which can be used whenever I need a phone number. Naturally, the subscribers will have their names. So, we will have subscriber name as string, maybe first name, middle name, last name. There could be other information related to the name that you can keep. You may want to have a helper class called photo to keep images of how does the subscriber look, and have the alternate text for the image also captured in this class. You may have class for varied kinds of ringtones, their IDs, names, and their audio files and so on. you will have a helper class contact containing the phone number, name and optionally the photo of a contact to create your every element of the address book. When the address book necessarily becomes a list of contacts, there could be more as well, as you can understand, but this is for the purpose of illustration. This is a basic set of kind of unitary concepts, I can say, utilities which are needed to be able to design my phone hierarchy in a easier way. Without this, I will need to kind of describe lot of very low level data like int, string and so on. I want to more make it object oriented, and these are objects of these classes will be frequently used in defining my actual hierarchy items. So, then I go to defining the hierarchy of phone by interfaces. So, the basic hierarchy, the easier relationship that I have is mobile phone. This is what we have done earlier. Mobile phone is a landline phone. So, landline is a generalization, mobile is a specialization, it inherits the properties of landline phone, the mobile phone. Similarly, smartphone is a mobile phone. So, mobile phone is a generalization of the smartphone and so on. It is a transitive relationship, so we could have it more, and this is the basic starting point that I identified that the three concepts landline phone, mobile phone and smartphone, and this is the interrelationships in terms of generalization and specialization. So, we will our hierarchy is multi-level linear, and we will start building up on that. So, the interfaces you have already seen this slide before. So, we have already identified the interfaces, that if these are the different concepts, then these interfaces basically tell us what is the service that this every concept does provide. Now, naturally you do not, I mean as a phone user, you are really not concerned about what happens when you do a call, or what happens when you have to do a redial, or how the ringtone files are basically created, and you are not concerned with any of that. All that you want to do is, I am a phone user, I must be able to call, I must be able to answer a call. I want to redial on a number, I want to add contacts, I want to put a photo for my contact and so on. So, here for every concept we define the interfaces that should be available for these concepts, and that is what we will try to model in terms of our inheritance hierarchy in this case. Okay. So, let us now this was mostly conceptual, these interfaces. So, now let us slowly start putting it in terms of our C++ paradigm, actual class paradigm, to define the interfaces and the state variables in every case. So, what I do, I take every concept and try to, based on the interface that I have already identified in terms of the hierarchy, I try to write a class corresponding to that. So, interfaces will become member functions, and using the helper classes, I will try to identify a set of state variables or data members that will be required to support these interfaces. So, if we look into landline, there are primarily two interfaces that we had identified. I have dropped the caller ID from here because it's little bit makes it more complex, it's more for illustration. So, I can say corresponding to this call, I will have a member function in the landline class, landline phone class, which will call. What does it need to know for the call? At least it needs to certainly know the phone number. So, it will take, I mean here I have taken a const pointer, it could be a const reference also, does not matter, I am not going into those details, but the basic idea is that it has to make a call, and that is what is identified by this particular method. Similarly, to answer, I will provide another member function which has to answer, right. assume that these are just action items. So, there is no return value from these. Now, since I have to make the call, I am expecting to call by the number. So, naturally as an entity of myself, I need to have a number of myself, only then I can make a call. I cannot make a call to a number unless I have a number myself. So, I assume that there has to be a state variable which is the phone number, and I have already taken care of these helper classes. So, assuming that those helper classes are there, I am not going into discuss about what those details of those classes are, those are like tiny concepts that are basically supporting me. Naturally, I have to have my name as a subscriber, and possibly I will have a ringtone. Maybe in a landline it is not settable. So, it does not appear in terms of the interface, but maybe it will have a default value. So, what else do I need? Naturally, I will have a constructor. When I get the phone, I construct my landline phone object with my number and my subscriber name, right. Ringtone I have kept optional. So, this is the basic rationale of a very minimal design for the landline phone class. In addition, I have provided a friend function for operator output streaming, which writes down say the landline number. This is not, you can see that this is a friend function. So, this is not the interface of the class, but this is more for us the developer, because while I develop this I may need to do some debugging, and to do debugging I need to be able to, at any point I should be able to print that object details, so that I can get a view about the state variables. That is the reason it is basically an output streamer to be able to write any object of this class, and this style will be followed everywhere. It is in fact a very generic style for any kind of object, any kind of C++ class design. Moving on, I have the mobile phone concept. So, now I try to do the mobile phone. First, the interfaces, the call will have call, which is by phone number, but it also has an option to call by name. So, I include another call interface, or in other words I overload the call. I will have to have an answer, there will have to be a redial, setting of ringtone, where I specify, assuming that there is some enumerated names of ringtones, I specify which ringtone. I should be able to add a contact given the phone number and the name, right. So, directly from the concept of the interfaces, I directly put them in terms of proper member functions of the class. Coming to the state variable, naturally I will need to have the phone number, the name, the ringtone, and certainly now I am assuming that there is a contact coming in. So, where will that contact reside? So, I need an address book. So, I am putting an address book here, which as you know should be a list of contacts. I am talking about redialing. If I redial, what does it mean? Dial the last number to which a call was made, either through call or by redial. So, I need to remember the phone number that was last dialed. I mean, this is the way you actually come to the state variables given the interfaces that you are trying to do. So, you are trying to take every interface and see, well, to be able to do this, what do I need to know in terms of the state variables. If I have to keep track of the last dial, I also need a member function to set this value, right. And this member function is not on my interface. This should get automatically set when I am doing a call or when I am doing a redial, and I do not want the users to be able to come in and set a number. because it is based on the internal functionality of the mobile phone. So, I provide for a member function here, but just note that this member function is provided as a part of the private specifier, which means that it is not visible externally, it is not a part of the interface of this class, but it is available to the developers for doing some tasks. Similarly, I have one for the showing number, which will help us in terms of debugging. We also have the output streaming. Once you get this this idea, then you will understand that when we take it further in terms of the smartphone, the things just keep on happening in the same way. I have two ways to call, I have a way to answer, I have a redial, I have a provision to set ringtone, I have add contact, I may be able to put photo in as a part of that, I have the constructor, the basic value. I need as state variables phone number, subscriber, name, tone, address book, last dialed, set dialed function for setting it, showing the number, and I will also I am expecting that the photo will also come in. So, if the photo comes in, then when I like the show number, I need to be able to show the number of the address book content, address book contact. Similarly, I need to have the size of and display the photo that comes in. So, these are kind of you can assume it in a different way also. You can assume that the entire display is an interface of the contact. So, you are just is going to use that interface, or you can assume that you have mechanisms for doing this in your own implementation, but the key point to note that the things that we are putting in here alongside the state variables are not part of the interface, they are basically part of our implementation. So, we have now been able to basically design the classes for the three concepts that are related to by the is-a hierarchy. And in the process, as the is-a hierarchy exists, as the is-a relationship exists between them, generalization, specialization exists between them, there are a lot of commonalities, and we need to refactor to remove those commonalities and bring in the actual inheritance mechanism of C++ in. So, in this refactoring process, say I know mobile phone is a landline phone. So, I put these two classes side by side. As I put them side by side, I find that there is a call here, there is a call here. Right? How will they be related as a specialization? Because I am trying to do this mobile phone, public landline phone to capture my actual is-a relationship. Right? As I do that, I will in mobile phone have a call function, call interface, which takes a constant pointer to a phone number. Right? But the way to call will be different. The internal implementation of the call will be different. So, I cannot use the implementation of this function in terms of the call in the mobile phone. So, I have provided the interface, provided the signature once again, and in other words, I am just connecting them by overriding this call function by this call function. I also observe that mobile phone has another mechanism to call, which my landline phone does not have. So, I have to retain that call function, which means that I am basically overloading. I see that I have to answer. So, there is an answer in the landline phone, there is an answer here, and I have just assumed that there is nothing else, nothing specific that you need to do for the answer. So, I do not need to override it, I just inherit it. Your actual situation you will have to resolve out. So, this is by this refactoring I am combining these two through the insertion of the is a constraint, the inheritance constraint, and refactoring by making one as a overriding member function, one as a overloaded member function, and one as a pure inherited member function. So does my constructor will change, because now landline phone becomes a base for the mobile phone. So, that base will have to be constructed. I have last dialed here, so that we will have continue to have here. And now, this is on the interface side. What do I have to do in the case of the state variable side? These three state variables are common. So, if I have them as a part of my base class landline phone, I will certainly not be able to redefine them. So, when I create a mobile phone, I will create a landline phone object as a part of it in the base, which will have the phone number, subscriber and ringtone for the mobile phone object that I am creating. So, I basically will omit these data members. So, that is why I have made them, commented them out. Rest of the data members naturally are new to mobile phone and will have to be included. Last but not the least, I have changed the placement of these data members and the kind of implementation required member functions. Earlier they were in private, now I put them in protected. They were in private, I have put them in protected, because unless I put them in protected, the next class, the specialized class mobile phone cannot use it. So, unless I make this protected, the next class, the smartphone, will not be able to inherit them, not be able to use them. We have seen all these. And in terms of the output streaming, I have discussed this with example earlier. I have to keep the streamer in the respective classes. Okay. Now, once you, so this is in terms of the object oriented analysis and design diagrams. Now, once you have understood this process, which is the basic refactoring, you will understand what happens when you want to enforce that mobile phone is a smartphone. Exactly the same kind of things happen. Now, this you are specializing. So, you have further cases of override. This here was overload, because it was introduced in mobile phone. In case of smartphone, it becomes a override, because it is already there in the parent. Your redial is also being made into a override, because in smartphone you will redial in a different way. All of these data members or member functions for implementation are already coming from the mobile phone class. So, you do not need them in the smartphone class, you just omit those, you are left with what is specific to that. Certainly, everything is in protected. You need to construct mobile phone based class in the constructor and need to provide the output streamer. So, the style becomes very similar, very repetitive, you just keep on doing that. And in this way, you are one by one stitching on the hierarchy in terms of the is a relationship, realizing that. So, finally, you put things together, put all of these. So, now I have erased all comments and all which were commented out, things which are not needed. So, this is your landline phone which you started with, this is your mobile phone, this is your smartphone put in a compacted form, and you have smartphone is a mobile phone, is a landline phone implemented. Right. Your hierarchy is in place, now you need to put in the member function details. Now, typically we will say this more, but typically when we do such a hierarchy, we are specializing from a generalized concept. So, smartphone can also have other specializations, and we have kept things in the protected to make sure that it can extend. Similarly, on the top is landline phone the ultimate? No. I want to talk about an abstraction called a phone. What is a phone? Where I can call, I can answer, I can redial. Anything, any device in which I can do that is a phone. So, I define a, and this is a part of the integration, I define a class which I call a abstract based class, that I do not expect, I have not seen that device, I do not expect a specific device like that, but I just want to say that this is the functionality which is in my mind, a phone. So, that abstraction is put in here. There are a lot of details in terms of C++ that exist here, which you have not covered yet. We will explicitly cover this, but assume, just know that this is kind of an abstract based class where you just have interfaces, you cannot have data members, you cannot have any object of that, but tells you the concept. And then what I do, instead of making landline phone as the root of the hierarchy, I make the phone the root of the hierarchy. So, it is kind of very nice, and on the top you have an abstract concept, then you have the hierarchy coming down, specializing, specializing, specializing further, and with this your entire hierarchy of phone systems is now integrated, perfectly refactored, and you have the entire thing in place. So, once you have done that, then maybe you would like to look at some of the expandability and see, okay, have you kept provision for that? So, what we have implemented in the hierarchy is this, this and this, right. So, I said it is transitive. So, mobile phone is transitively is a landline phone, but there are different other kinds of like speaker phone, cordless phones, which are between landline phone and mobile phone. There is a video phone, tablet phone, there are Android phone, there is iPhone, specialized forms of smartphones and so on. So, just try to look at that if this is the hierarchy that I have done, I can actually put things below this, I can put things below here, I can insert in the middle, all my hierarchy is open for future extension. Extendability is very important. Here I have not shown the abstraction, which will come something like a phone here if you do the complete diagram, but this is an abstract one, right. So, this by this we have I have tried to show you that for a given phone hierarchy example, how to go about doing the design process with inheritance and put everything together. We will take up more through tutorials and assignment examples to build your, but building this skill of implementation of hierarchy will be very, very key to learning the C++ programming in the real strength of object orientation. Thank you very much. See you in the next module.